You use electricity every single day. You flip a switch and the lights turn on instantly. You plug in your phone and it begins to charge. You turn on a fan and it starts spinning without hesitation. It all feels so normal, so predictable, that you stop questioning it. And because of that, you assume something dangerous. You assume you understand it. If I asked you right now, what is electricity? You'd probably give a quick answer. Something about electrons moving, something about current flowing through wires. It sounds correct. It sounds scientific. It even sounds complete. But here's the problem. Those answers don't actually explain anything. They just give names to things you don't fully understand. Electrons are moving. Okay, but why are they moving? What is pushing them? And more importantly, how does that movement turn into light, heat, or motion in the real world? Most people never go past that point. They accept the explanation because it feels familiar. It matches what they've heard before. It sounds like knowledge, but familiarity is not understanding. It's an illusion. And electricity is one of the best examples of that illusion, because the way you've been taught to think about it is simple, clean, and comfortable. It behaves like something you already understand, something like water flowing through pipes, something that moves from one place to another, doing work along the way. That picture feels right, but it isn't. It hides more than it reveals. And the moment you start questioning it, really questioning it, you begin to notice the cracks, the parts that don't quite make sense, the details that don't line up with reality. Like this, when you flip a switch, why does the light turn on instantly? If electricity is just electrons moving through a wire, should it take time for those electrons to travel from the power source to the bulb? Shouldn't there be a delay? But there isn't. The light turns on immediately. That's your first clue. Something about your understanding is incomplete, because what you think is happening isn't what's actually happening. And once you realize that, once you accept that your confidence might be misplaced, something shifts. You stop assuming. You start questioning. And that's where real understanding begins. At some point, someone gave you a picture of electricity that felt easy to understand. Electricity flows like water. It moves through wires, the way water moves through pipes. You turn on the switch, and it flows from the source to the device. Simple, clean, almost satisfying. And that's exactly why it's so dangerous, because it feels right. Your brain loves this model. It fits perfectly with everything you already understand. Water flows, air flows. So of course, electricity must flow too. It becomes a story you don't question, because it makes the invisible feel familiar. But here's the problem. That picture is deeply misleading, not because it's completely wrong, but because it hides the most important part of what's actually happening. Think about water in a pipe. When you push water in at one end, the water itself travels through the pipe. The same molecules move from one place to another. It's physical, visible, intuitive. No, apply that to electricity. If electricity worked the same way, then electrons would have to travel all the way from the power source to your device. They would move through the wire like tiny particles flowing through a tube, but they don't, not in the way you imagine. In fact, electrons move incredibly slowly, so slowly that if you could watch them, you'd be surprised. Inside a wire, their average speed is about 1 millimeter per s-econ. That's almost nothing. At that speed, it would take minutes for an electron to travel even a short distance across your house. But when you flip a switch, the light doesn't wait. It turns on instantly. So now you have a contradiction. If electrons are moving slowly, how does the effect happen so fast? The water analogy breaks right here, because electricity is not about something traveling from point A to point B in the way a substance moves. What you're seeing is not flow in the traditional sense. It's something else, something that spreads, something that propagates. Imagine a long line of people standing shoulder to shoulder. If you push the first person, they don't run down the line. Instead, the push is transmitted through the entire line almost instantly. and the last person feels it right away. That's much closer to what's happening inside a wire. The electrons are already there. The wire is full of them. When you apply a voltage, you're not sending electrons on a journey. You're creating a push that spreads through the entire system. The effect moves fast, even though the particles move slowly. And that changes everything, because now electricity is no longer a flowing substance. It's an interaction, a chain reaction, a system where local movement creates a global effect. The water model didn't just simplify things. It led you in the wrong direction. It made you think in terms of objects moving, when the real story is about influence spreading. And once you see that, the old picture starts to fall apart. Electricity isn't what you thought it was, not even close. Now we come to the moment where everything starts to feel strange. You flip a switch, and instantly the light turns on. No delay, no waiting, just immediate response. Your intuition tells you something must have traveled from the switch to the bulb almost instantly. But we already know that's not what electrons do. They move slowly, almost unbelievably slowly. So if they're not rushing through the wire to make the light turn on, then what's actually moving? To understand this, you have to stop thinking in terms of objects and start thinking in terms of effects. The wire in your wall is already filled with electrons. They're everywhere, packed closely together, like a crowded room where no one has much space to move. When you flip the switch, you're not sending new electrons down the wire. You're disturbing the ones that are already there. It's like tapping the first domino in a long line. The domino at the end falls almost instantly, not because the first one traveled all the way down, but because the effect of the push moved through the entire system. That's what electricity really looks like. When voltage is applied, it creates an electric field, a kind of invisible influence that spreads through the wire at nearly the speed of light. This field pushes on the electrons already inside the wire, causing them to shift slightly. Each electron nudges the next, that one nudges the next, and so on. The movement is tiny, almost negligible at the level of individual particles, but the effect spreads incredibly fast. So fast that it feels instantaneous. What reaches your light bulb is not a stream of electrons arriving from far away. It's the influence of that electric field propagating through the system, telling electrons everywhere to move together. And when those electrons move, even just a little energy is transferred. Red, the filament in the bulb, resists that movement, heats up, and begins to glow. Light appears. So the real answer is this: nothing is racing through the wire in the way you imagine. What's moving is the disturbance, the signal, the influence. Electricity is not about particles traveling long distances at high speed. It's about a coordinated response that spreads through a system already filled with charge. And once you see that, something clicks, because now electricity stops being a flow and starts becoming a pattern of motion, spreading through matter, driven by invisible fields. So if electrons are barely moving and a real effect is spreading through something invisible, then what is actually carrying energy from one place to another, this is where the story changes completely, because the energy in electricity doesn't flow inside the wire the way you've imagined. It flows around it. That sounds impossible at first. The wire feels like the obvious path. It's the thing connecting everything together. So naturally, you assume the energy must be traveling through it, but the wire is not the main pathway. It's part of a larger system. When you apply voltage, you don't just move electrons, you create an electric field that exists not only inside the wire, but around it, extending into the space surrounding the conductor at the same time. The movement of those electrons creates a magnetic field, and together these two fields form something powerful. They guide the flow of energy not through the wire, but through the space around it. Imagine energy traveling alongside the wire, like an invisible stream hugging its surface. The wire doesn't carry the energy in the way a pipe carries water. Instead, it shapes and directs the fields that carry energy through space. This idea is captured in something physicists call the Poynting vector. You don't need the math to understand the meaning. It simply describes the direction in which energy flows, and that direction is not inside the wire. It's around it. So when you turn on a device, energy moves from the power source to the device through the electromagnetic field surrounding the wires, not just through the motion of electrons inside them. The electrons are important. They respond to the field. They help sustain it. But they are not the main carriers of energy. The field is, and this changes your entire picture of electricity, because now electricity is no longer something confined inside metal. It becomes something that exists in space itself, a dynamic interaction between electric and magnetic fields, continuously transferring energy across distance. The wire becomes a guide, not a pipeline, a structure that shapes the flow rather than containing it. And once you understand that, the old model disappears. Electricity is not a substance moving through a path. It's a pattern of energy flowing through fields. Now step back and look at what just happened. You started with a simple idea: electricity flows through wires. It felt obvious, almost too obvious to question, but piece by piece, that picture began to fall apart. The electrons weren't rushing the way you imagined. The energy wasn't traveling where you thought it was. And now you're left with something very different. Electricity is not a substance. It's not something moving neatly inside a path. It's a relationship, a dynamic interaction between fields that exist in space, guiding energy from one place to another without ever needing a visible carrier. The wires are just part of the system, structures that shape and direct something much more fundamental. And once you see it that way, something deeper begins to shift, because electricity is not the exception, it's the rule. The same kind of invisible interaction that carries energy through your walls is happening everywhere around you, all the time. Every force you feel, every motion you observe, every signal your body processes, it's all rooted in fields interacting across space. What felt like a mechanical world, solid objects pushing and pulling, is actually something far more subtle, a field-based reality, where cause and effect don't always require direct contact, where influence spreads through space itself, and that realization changes how you see everything. The light turning on instantly is no longer just a convenience. It's a clue, a glimpse into how the universe actually works beneath the surface. A reminder that what feels simple is often just a simplified version of something much deeper. Because the truth is, you were never watching electricity flow. You were watching energy guided by invisible fields. You were watching a system respond as a whole, not a substance traveling from one point to another. And once that clicks, once you let go of the old picture, you don't just understand electricity better, you understand reality differently.